Okay, now we are starting the next part after the completing the square. That is a application. So after you completing the square, then you should know how to interpret the completing the square form and use them into the examination questions. So a lot of questions being asked in this area in an examination. So now look at the constants here. The constant here is A. If the A is a positive value and it represents a minimum graph, and if it is A is a negative and it represents a maximum graph. Minimum graph means the graph will be looking like this, something like that. It's a minimum graph. Maximum graph means the graph will be looking something like that. Then we need to know how to determine the symmetry line. Okay, the symmetry line is in the middle, is this part. So x plus minus b is equivalent to 0. Therefore, x is equivalent to negative plus. So the plus go the other side is negative, negative goes as a b. So it means the symmetry line is this part. So we make anything in the bracket and make it equal to 0, you get your symmetry line. Okay, and the third part that you can understand is look at the plus minus c here. If this is the plus minus c, that means the y is a plus minus c. If a is a maximum, then this is a maximum value. If a gives you minimum, then this is a minimum value. So therefore, y equals to plus minus is actually maximum if a is less than 0. If a less than 0 is maximum. If a is more than 0, then y equals to plus minus c is actually minimum. So if you know the value where the symmetry line and you know where is a maximum, that means you can find the stationary point or you can find the turning point. The turning point is a value of x equals to negative plus b and y equals to plus minus c. And there is a third part of the question. We have the note if the graph are reflected on the y-axis, the y is equal to f negative x, and if it is reflected in the x-axis, then y equals to negative fx. It's seldom asked in examination question. So now I'm going to use these formulas. Of course, you're going to have a difficulty to understand the formula, but we will see through the example to understand what is being written here. Okay, let's take the first example. Okay, if you look at the first example, you are given y is equivalent to x squared minus 5x minus 6. Okay, we have completing the square. Okay, we're going to complete the square. Correct? We're going to complete the square. What we're going to get now in completing the square is we found that this is what? 1. Therefore, we're going to use bracket square minus bracket square, and minus 6 is minus 6 remain. So this is a 5. This is negative. Therefore, this is negative. This is 5. So you get 5 over 2 and minus the same value repeat here. This is how we do the completing the square. Then after that, simplify. This is square root. You got 25 over 4. So negative 25 over 4 minus 6 is actually negative 49 over 4, and this is a completing the square. We done this in the earlier lessons. Same example. Now we're going to do sketching the graph. Okay, this is we already explained in the how to sketch graph. Now look at this one. Y equals to negative 49 over 4. So therefore, y equals to negative 49 over 4 is somewhere here. Okay, we name this line y equals to negative 49 over 4. Then anything in the bracket, you make it equal to 0. That means I make it x minus 5 over 2 equals to 0. So I got x equals to 5 over 2. So this is a line where x equals to 5 over 2. So that means we no need to see this part, we no need to see this part. Therefore, you see only x squared. X squared means it's a positive graph. That means this is a minimum graph. So that means this is your turning point. The graph goes like this. And when it turns back, we have a problem here, here, and here. What happened? I'll make it x0. don't substitute here, you substitute in this line. Okay, when you look at this line, this is the x square minus 5x minus 6. So you substitute 0, 0 and negative 6. That means y equals to negative 6 when x equals to 0. So y equals to what? Negative 6 when x equals to 0. So now y equals to negative 6 when x equals to 0, it means it cuts at the negative 6 somewhere here. So the graph goes like that. And this value is negative 6. So now you draw the graph of quadratic equation which is given to you. Now I'm going to do the application. The first application I have based on the graph is actually the first thing I need to find out what is the equation of the symmetry line. The equation of the symmetry line is this line. Okay, this line. This line is actually equivalent to this part where you make it equals to 0. That means x minus 5 over 3 equals to 0. And that's what is being mentioned in your formulas. You see, symmetry line. Symmetry line, when x plus minus b equals to 0, then simplify this, you got your symmetry line. So here is x minus 5 over 2 equals to 0. So you get x equals to 5 over 2. So the symmetry line is actually x equals to 5 over 2. Then they ask you whether the line is maximum or minimum. Now since the equation which is given to you, look at the equation. So the equation given to you is y equals to x minus 5 over 2 square minus 49 over 4. And here is positive value. This is 1 is a positive value. So if it's positive value, then you look at your formula again. If it is a positive value, so you get the positive value, it means it's a minimum graph. So that means A is more than 0, A is a positive value, then it's a minimum graph. So therefore, this is a positive value here 1, therefore this is a minimum graph. So this is a minimum value, so the y minimum is actually equivalent to this value, negative 49 over 4. So look at the formula. The formula says that the minimum value is y equals to plus minus c, and is a minimum if a is greater than 0. So now it means straight away we can see that this is the equation. So y equals to negative 49 over 4 is a minimum value. Now we need to get the turning points. Now to obtain the turning point, or sometimes we call this a turning point as a stationary point. So this will be the answer because this is a turning point. This is a stationary point. So we got the x value, we got the maximum minimum value. So combination of these two is actually the turning point. So the turning point is actually equals to 5 over 2, the value of x, followed by the value of y is negative 49 over 4. So I found the turning point. Now we continue with the second example of the application. Okay, second example of the application. Okay, when we talk about second example, the a value is already been 2. Okay, we got 2x squared minus 8x plus 3. Now these questions are already discussed in the previous example. Okay, you can check the previous example in a model 2 under the completing the square. I already got this answer as a 2x squared x minus 2 squared minus 5. So where I need to factorize the 2, I take out the 2, therefore I got here 8 over 2. 8 over 2 is 4. Then this value must be divided by 2. Therefore 4 divided by 2, I got 2 here. And the same value put it here. Then this is 4. 4 times with 2, I got negative 8 plus 3, I got negative 5. And we completed the square. Now we need to, using this thing, this equation. So now I'm going to, first thing I'm going to do here is sketch the graph. So now here y equals to negative 5. So y equals to negative 5 is somewhere here. And x equals to 2 is somewhere here. Okay, this value is y equals to 5. Because you look at here, y equals to negative 5. Then this value, make it anything in the bracket, equals to 0. So x minus 2 equals to 0. So I got x equals to 2. Therefore, x equals to 2, it means this is a x equals to 2 line. And this is positive, therefore this is a positive sign graph. So the graph goes like this. So now the equation is y equals to 2x squared minus 8x plus 3. So when x is 0, 0, 0, 3. That means y is equals to 3. That means it's cut at y equals to 3. Okay, this is 3. So this is how the quadratic graph look like. Okay, now I need to find the asymptote line. Asymptote, the symmetrical line. The symmetrical line is, this line is a symmetrical line. So if this is a symmetrical line, that means anything in the bracket, say anything in the bracket is equals to 0. So the symmetrical line is x equals to 2. Then we need to find out whether this is a maximum or minimum. Since this is a 2, 2 means it's a minimum graph. If this is negative 2, then it's called as a maximum graph. So since in this case it's 2, therefore it's less than 0, so it's a minimum graph, so this is called as the y minimum is actually equals to y equals to negative 5, so equals to negative 5. Okay, and the third question is a turning point. Turning point is a combination of a symmetry and this, so the turning point is actually 2, negative 5. Okay, now we have done the question. Okay, now the graph that we have sketched here has no intersections of the x-axis. Now to find the intersection of x-axis, intersect x-axis means, note given here, y is equivalent to 0. Okay, y equivalent to 0. When y is equivalent to 0, so 0 equals to 2x squared minus 8x plus 3. This cannot be factorized. So what you do, you use your calculator to calculate what is the value of x. So you use your calculator to calculate under the equation. You will find that x equivalent to 0.4189 and x equals to 3.581. Therefore, this value is actually 3.58. And this value will be 0.42. So now we got this value is 0.42 and this value is 3.58. Now we can continue the graph. If the latest syllabus, we are going to apply how to sketch the modulus graph on quadratic. So if you look at my previous notes, which is I mentioned earlier, that in order to sketch your modulus graph, the first step is sketch without the modulus. Now to sketch without the modulus, actually we already sketch here without the modulus. The second step is under the sketching the modulus concept is remain the graph above the x-axis. So the above x-axis is this part. So this part is above the x-axis. So I'm going to remain that part. So I got it here. Okay, this value is 3 and this value is 0.42. And the other graph is above the x-axis is this part. So this part also must be remain. So I'm going to sketch here. So this is remain. So this will be the 3.58. Okay, the symmetrical line in between these two is actually here. So this value is x equals to 2 and this is a negative 5. Now reflect to the x-axis. This is reflected on x-axis. This is going to be y equals to negative 5 become y equals to 5. So this will be y equals to 5. So this value is 5. So the graph will reflect it here. So that means this portion is reflected here. So this is the one. So this is how the modulus graph look like. Okay, now we're going to section E. What will happen if the same graph, we need to determine domain and range if it is given a certain boundary of the class. So if they give you, in this case, I want to calculate, they give you in between negative 2 and 6. So I want to calculate what is the value of y when x equals to negative 2. So when x equals to negative 2, so I got modulus. So put negative 2 inside here. 2 times, here is negative 2 power 2 is 4. 4 times 2 is 8. So we got 8. Then you put here negative 2. So negative 8 times the negative 2 is 16. So this is plus 16 and plus 3. So this will give me y equals to 8, 16 is 24, plus 3 is 27. So the other one is when I take x equals to the boundary which is given to here is 6. So I put that x equals to 6. So I got y is actually equivalent to modulus 2 times with 6 square minus 8 times with 6. Okay, then plus 3. So this gives me modulus 6 square is 36. 36 and 2 is 72. 72 minus 8, this is 48 plus 3. So that means 72 minus with 48, you'll be getting 24. Sorry, 24. 24 plus with 3 is 27. So this will be 27. Now with all these values, we need to draw the graph. So the graph is here. This is a 0.42 and this is 3.58. So I'm going to draw. So this is the graph in this part, in the middle here. And this value is 2 and this value is 5. And this graph is when it's 2, negative 2 is stop at 27. So 27 is here. Cut like that. So this is 3. So this is negative 2 and this is 27. And because of negative 2 is not included, therefore this is put a circle here. And now we also got when x equals to 6. Okay, when x equals to 6 is somewhere here. And the value of y is 27. So the graph will be here. So same thing, it comes here and this is 27. So this 6 is actually included. So now your graph will be in this shape. Now you need to find the range. Range means I need to find the value of y where is a maximum value of the y is 27. If I take this coordinate is not 27, but this is included 27. Therefore, the answer is included 27. So the maximum value is 27 and included. So the lowest value here is what? In the y-axis, the lowest value here is this line. So this is the lowest value. This value is 0. And 0 is included. So because here only is not included, the rest all included. So 0 is included. Therefore, this is included 0. Now we have completed the question number 2.